You ever see one of those news reports, the ones that claim to know what an entire country is thinking, but they only talk to like 1,000 people? It just feels impossible, right? Kind of like a magic trick. Well, today we are going to pull back that curtain because this isn't magic at all. It's science. And we're going to demystify how to find the right sample size together.
Okay, let's just get right to it. How in the world can a tiny little group of 1,000 people possibly speak for millions, sometimes hundreds of millions? It seems like it defies all logic, but trust me, there is a solid scientific answer to this puzzle, and it's actually pretty fascinating. So, how do researchers come up with this magic number? I can tell you it is definitely not a guess, and they're not pulling it out of a hat. It's the results of a really rigorous scientific process. It's actually a whole field of study that's all about answering one single question. How many people do we really need to ask? And that whole method, it has a name: sample size determination. Now, the key words to lock onto here are mathematical and minimum. See, the goal isn't just to survey as many people as you can. The real challenge, the real art, is to find the smallest possible group that still gives you results you can trust. It's all about being efficient and precise. And the outcome of that whole determination process, well, that's your sample size. That's the final number. That's our 1,000 people who are actually going to be in the study. So the determination is the method, the sample size is the result. Simple as that. All right, so if this whole thing is a mathematical process, what are the inputs? What goes into it? Honestly, the best way to think about it is like a recipe. There are a few core ingredients that determine the final number, and getting that mix just right is everything. And here they are, those key ingredients. First up, population size. But here's a wild fact for you. Once your population gets big enough, say over 100,000, the sample size you need barely changes. A sample of 1,000 people works almost as well for a country of 300 million as it does for a city of 1 million. Crazy, right? Then you've got accuracy. The more precise you need to be, the bigger your sample has to be. Of course, time and cost. Those are the big, real-world limits. And finally, there's variability. If you're asking about something where opinions are all over the place, you're going to need a much larger sample than if pretty much everyone agrees. So this brings us to what I like to call the Goldilocks problem. If you go too small with your sample, your results are pretty much meaningless. But if you go too big, you're just wasting time and money. The goal is always to find that number that is just right. And this really shows that trade-off perfectly. If your sample is too small, your findings might just be a total random fluke. They're not scientifically reliable. But if it's way too large, you're just burning through resources for an absolutely tiny gain in accuracy. It's a constant balancing act between being confident in your results and, well, being smart with your budget. Okay, so we know the what and we know the why. So now let's take a little peek inside the statistician's toolkit to see how they actually do it. Turns out there are two main methods that researchers really rely on. Method number one is the most direct approach. You just use a formula. Statisticians can plug in all those ingredients we talked about, like how accurate they want to be and how much variability they expect, into a proven equation. A really common one is called Cochrane's formula, which is perfect for big populations. The formula then just spits out the exact sample size they need. It's a super powerful tool for a really custom calculation. But you don't always have to break out the calculator. The second method uses pre-calculated reference tables. So years ago, researchers like Creechy and Morgan did all the heavy lifting for a bunch of common scenarios. So if you've got a population of, say, 50,000 and you want a standard level of confidence, you can just look up the answer in the table. For a lot of studies, this is a fantastic shortcut. So we've covered the what, the why, and the how. But what does all this really mean for you? Well, it means you now have this powerful new lens for looking at the world, especially at all the data and news that gets thrown at you every single day. Here's the most important point of all. This knowledge empowers you. It helps you go from just being a passive consumer of information to an active, critical thinker. So now, when you see a poll or a study, you can ask the most important question of all. Is this claim actually built on a solid foundation? So, I'll just leave you with this. The next time you see a headline that makes some bold claim about what people think, I really hope you'll pause for a second. I hope you'll look for that number, and I hope you'll ask about the sample size. Because now you know it's one of the most important questions there is. Thanks for joining me.